Hi guys, happy day. We are going to take a look at lesson 12 today in module 3, and there is so much here. I don't know if I can get through it in a half hour, seriously. Let me just try to buzz through all this, and you guys are going to have to choose a method that works for you and use it consistently. There are, again, multiple methods to subtract fractions greater than or equal to 1. And so let me just show you in the notes, and I'm going to go through really fast, and I'm so sorry. I know it's going to be confusing for some people, but I'm just going to go through and explain it. You can watch it over and over so that you can see what's happening. And then when we get into the book, I'll try a couple different methods and show you why I like certain methods over others. So when subtracting fractions, if you have a fraction that is small, like 1 out of 5 parts, coming away from 1 out of 2 parts, this is tiny, this is bigger. So when you find the common denominator, you can do the subtraction with no problem because 1/5 is smaller. You're taking away something smaller. But sometimes you will have fractions that are quite large that you're trying to remove from something that is not quite as big. And so if you have something like 1 3/4 minus 6/7, this is larger than what you have. So we had talked in one of the previous lessons about other strategies that you can use to work with the subtraction so that it's easier. Okay, and then I know you're probably going, what is this digress? Now, this is just to remind you that every fraction is a division problem. So if you weren't really sure about which fraction was bigger, you could always divide 3 by 4, which I did here, annex a decimal and 2 zeros, and find out the exact percentage and decimal value so that it's easier to compare. And I had referenced this in an earlier video. I said, remember, I really prefer working with decimals because I can't always tell what the size of a fraction is. Well, here it is, 6 divided by 7. Annex the decimal and a couple of zeros, keep going, and then you can see that if you were to round this, that this is approximately 86% compared to 75%. So they're pretty close, but that this fraction has greater value. You can always do that for any fraction if you ever want to know exactly. It's so much easier to compare their value when it's in decimal format. But I digress. That's why I wrote that. So then we have multiple methods to do this type of problem when your subtrahend, I think is what it is greater than your minuend, right? And I hope I'm using those words right. So if I end up having a problem like 1 21/28 minus 24/28, the problem here is that I need some help because I don't have enough to pull from. So what you can do, this is one way, is to use one of your whole, and I may have more than one at some point. I may have 4 in 21/28, but you only need to use one. Change it to a fraction that represents 1, which you get to choose the denominator. Because remember, any number over itself equals 1. So here I'm going to choose 28/28, add it to the 21, or just take this, sorry, that's the wrong one. I'm going to do that on another one. Take this 28/28, subtract the 24/28. This is like what we did in a couple lessons ago. So just use this big one, subtract this, and get 4. Then combine that with what I haven't bothered to use yet, and you should get 25/28. Okay? Now the old way is to create an improper fraction by swooping up everything into your first whole and then doing the straight subtraction. And a lot of your parents will say, this is a perfectly good method and it works great. And I'm going to say, yes, they are right. It does work great. But as you'll see on some other problems, it's actually easier to use the new way for other types of things. And in this version, you do 28 times 1 because you multiply how many sets of 28 you have, add your numerator, so 28 plus 21, you get 49, and then do the subtraction straight across like you would, 49 minus 24, and you get 25/28. So that looks real easy here, but it won't always be that straightforward. So another method is to subtract the whole numbers to simplify everything as much as possible. Now my new whole, is, WHOLE, is 1 1/4. This is what I have left, okay? And I still have to subtract the 1/2, okay? So finding the common denominator, no, sorry, oh my God, I'm like misspeaking, I'm so sorry. So 3 1/4 minus 2 1/2, take away just the whole, then you still have to take away the fraction, find a common denominator. See that I can't do 1/4 minus 2/4. I can't take 2 from 1. So use the 1, subtract what you need to, and then put back the 1/4 when you get the answer. 4/4 minus 2/4 is 2/4. The answer is here. And then you add back the 1/4 to get 3/4. Now what's another way? What if you wanted to just do 4 plus 1 and get 5/4 minus 2/4 and just do it in one step? You still get 3/4. So there are many different ways to go about this. Here's the third method, and this one's actually pretty fun and easy. But you have to keep track of where you are. If I have 3 1/4 minus 2 1/2, let's just take this out for a second. Let's just pretend. What if I had 3 minus 2 1/2? Well, if I had 3 minus 2 1/2, then that would leave me with 1/2. 3 minus 2, so 3, 2, 1, and then 1 minus 1/2 is 1/2. Here is everything that's left after taking your whole number and subtracting everything that I had to take away. But don't forget you had that. So put it back, find the common denominator, and you can get 3/4 this way. So these are just different methods to all these subtraction problems that we're going to be working on. And I have a couple things that I'll show you from my previous booklets where I worked a lot of different things out, and I'll kind of show you how it's not always beneficial to use the old-fashioned method. So let's jump in. It's like super blurry. Sorry. Okay, here it comes. 3 1/5 minus 2 1/4. So I don't really want to do it the old way ever. If you guys want to do that on your own, you will, again, just be on your own. You can, let's say, take your 3 minus 2 and get 1. Okay. And then I have the 1/5 minus the 1/4. So I haven't even touched either of these. But I see that 1/5 is smaller than 1/4. So when I want to subtract the 1/4 from something, I could use the 1, or I can wrap this up into an improper fraction at this point. So I have so many options. If I was to say, do the improper fraction now, I can do that. 5 times 1 is 5 plus 1 is 6. Now I have the whole thing, and I still have to take away fourths. So find a common denominator, which is 20. So this is why you have to be good at finding the common denominators so you can kind of work through them quickly. If 4 is my scale factor, then I would have 24 here, and 5 is my scale factor, so I would have 5 here, and then 24 minus 5 would give me 19. And so this is one way of solving. If I wanted to take the 3 minus the 2 1/4 and just do this whole subtraction thing right from the 3. 3 minus 2 is 1. 1 minus 3, 1/4 is 3/4. Okay, so this is my answer to taking this whole thing away. But what about this part? Well, you got to put it back. So that you end up with an addition problem. But you still have to have a common denominator. And you still have your scale factor. And you would still end up with 19/20. So I don't want to confuse you with all these different methods. You basically choose one way that you like to do it, and then you need to do that consistently. But just know that today's fractions are going to be larger in the second part that we're pulling away from the whole, and these will be smaller. All right, so let's get to it. And then, I mean, I could go on and on about all the different ways that we used to do things. So let's take our 4 and subtract 3 3/4. Okay, so 4 minus 3. 3, 2, 1. 1 minus 3/4. That leaves you with, 1/4. 1/4. Okay, also you can think about the difference between 3 3/4 and 4. It's 1/4. So now I have taken away my whole subtrahend. And I only used the 4 from my whole, or the minuend. I hope I'm using that right. So I need to put back the 2/5. And I need a common denominator to do that. And since 5 is my scale factor here, multiply. And since 4 is my scale factor here, and then we have 5 plus 8, and we get 13/20. And that's just one way to do it. Okay? There are many different ways. Let's do another one. Let's do one where we pull from the whole thing. So let's do 7 minus 4 is 3. So I've taken care of this, but I still have 1/5 minus 1/3. So what happens if this is too big? Okay, because thirds are bigger than fifths. So I need to, well, I'm going to have a common denominator at some point. So let's get one now. I need 15ths, and if it's 5 times 3, then it would be 3 times 1. And if it's 3 times 5, then it would be 5 times 1. Now you can see my subtraction problem has 3 minus 5, which I cannot take away 5/15 from 3/15. So what I need is more 15ths over here in my whole. So what you can do is you can take 1 from the whole, and you can either subtract the whole thing from the 1, or you can combine it with this one. So I would put 2 are left, and I'm going to use one of them. Okay, so this would be subtract 1, call it 15/15, and add that to what you have. So now I have 18/15. I can manipulate these numbers. I think the hardest part to understand is that you have control over what the whole looks like. You can flip it around, you can change it around, it's still the whole. 2 and 18/15 has the same value as 3 and 3/15. It's just in different places, because this fraction right here is equal to 1 and 3/15. 1, add it here, and 3/15. Anyhow, 18 minus 5, so 2 and 18/15 minus 5/15 would be, now I have enough, and I end up with 2 and 13/15. Okay, and again, this is just one way. If you wanted to do 7 minus 4 1/3 in one step and then put back the 1/5, you are totally welcome to do that. So 7 2/5 minus 5 2/3. Let's do the whole subtraction. 7 minus 5 2/3. We'll do the whole thing in one step. So 7 minus 5 would be 2, but we still have to take away 2/3. So 2 minus 2/3, that's not a whole one, so it's 1 and 1/3 is what you're left with. Okay, so now this whole thing has been subtracted from the 7. So I already took care of all that. But I have to put back the 2/5. I have not accounted for this in my problem. So once you have your answer, the difference between 7 and 5 2/3, put it back. I need 15ths, must have a common denominator. 5 is the scale factor. 3 is the scale factor for this one, so 3 times 2 is 6. Add, bring down the 1, and add the numerators, and you get 1 and 11/15. Okay? Now what I want to show you is in years past I've had longer discussions with the kids about why I should do one version over the other. And so hopefully this will focus in a second so you can see, what it takes to sometimes use the old method. Now in the old method, you would simply wrap everything up together in an improper fraction. So 5 times 7 is 35 plus 1 is 36. And then 3 times 4 is 12 plus 1 is 13. So the whole problem can be written in this improper fraction minus improper fraction. But you have to have a common denominator. So when using 3 as a scale factor, you'll get 108 15ths minus 65 15ths, which would give you 43 15ths, which is just more, it's more work and more calculating, and you'll still get 2 and 13 15ths after doing all that work. So what we're trying to avoid is doing all that extra work because I want this to be simple. Okay, so moving along, and 4 2/7 minus 3 1/3. Find the method that works best for you, the one that is always fun. Let's do this one on this side and this version on this side. So 4 minus 3 is 1. I'm just taking the whole numbers, and I still have 2/7, and I still have to take away 1/3. Okay, we need 21sts because that's our common denominator. 3 is a scale factor, so multiply 2 by 3 to get 6. 7 is a scale factor for here, so 7 times 1 is 7. Can't take 7 from 6, so we need to use this 1, have it be 21 21sts instead of, and instead of adding them together, let's just take the 7 21sts away. Okay, let's just take 7 21sts away. I get 14 21sts, but I need to put that back with the 6. And so I end up with 20 21st. There's so many different ways you can do this. It's really hard for me to choose one. I want you to choose the one that is best for you. 9 2/3 minus 2 6/7. Let's take the whole thing away from 9. 9 minus 2 6/7 from the whole number. And if you go 9 8 7, it's 7 minus 6/7. So 6 1/7. But got to put back the 2/3. So now I need 21sts. And 3 is my scale factor here, so multiply by 1. And 7 is my scale factor for this one, so multiply by 7 and get 14. And we end up with 6 17 21st. It's so much less writing than if you had to make the improper fractions. It really is, it's a big time saver. Okay, and 17 2/3 minus 5 5/6. And again, let's do the subtraction here and just call this 12. And then have our 2/3, and we need to take away 5/6. I need a common denominator. Let's change this to 6ths and leave the 5/6 alone. The best common denominator is the lowest one. To get from 3 to 6, it's times 2. So I'm not using the 6, I'm using a 2 as a scale factor. 2 times 2 is 4. And I can see that now I have 4 minus 5, which I can't do. So I'm going to take one of these, okay, and call it 6/6, and I'm going to add it to here to get 10/6. And then I can subtract my 5/6 from the 10/6. And I end up with 11 5/6. Okay. I know this is really hard. I know this is a hard lesson. Now for this one, let's do the 18 minus 3 and 3/8. And we'll take the whole thing away from the 18. So 17, 16, 15. And then 15 minus 3/8. Okay? So you're going to go down and the difference. So you need the difference. And then 14 and 5/8. I need to put back the third. And we need a common denominator. So let's do 14 and some 24ths. And use our scale factor. 3 is the scale factor for this one. And 8 is the scale factor for this one. So now I have my equivalent fractions. And 14 and 23 24ths. So there you go. I hope that is okay clear for you guys. I wish I could spend like an hour and do every single type of method so that you could see how these work, but I just don't have enough time. All right, Toby wrote the following: 7 1/4 minus 3 3/4. And it's equal to 4 2/4, which is equal to 4 1/2. Is he correct? Draw a number line. So let's draw a number line and find out if he's correct. 7, we need up to 8. That's our big, and we need to get down 8, 7, 6, 5. Oops, that's probably too far apart. 7, 6, 5, 4, 3. Okay, so fix. There we go. There's your number line. All you need is from about 3 to 8. And we start at 7 1/4. So if you split that up and start a little higher than 7, okay, that's where we are, 7 1/4. Then we have to take away 3 and 3/4 more. So I'm going to go like this. 1, 2, 3. And when I do that, I should be at 4 1/4, right? But I still need to take away 3/4 more. So 7 minus 3 equals 4. But think of the also needing to take away the minus 3/4 more. And that doesn't even account for the 1/4 that we had at the beginning. So I have to take away 3/4 more. So divide up the next section, and we keep going. Keep going in a negative direction when you subtract. Oh, that's terrible writing. D-I-R-E-C-T-I-O-N. 1, 2, 3. Minus 1/4, minus 1/4, minus 1/4. And so where do we end up? We end up at 3 1/2. So the whole thing should equal 3 1/2, not 4 1/2. It's like he changed directions. It's like he was only subtracting with the whole number and then didn't even account for about the fractions. So no, he's not correct, and our number line correctly shows where he should be. 3 1/2 is where he should be. Okay, only 2 more problems. Gotta be quick. Mr. Neville Ice Guy, N Ice Guy, nice guy, mixed up 12 3/5 gallons of chili for a party. If 7 3/4 gallons of chili was mild and the rest was extra spicy, how much extra spicy did Mr. Ice Guy make? So if we have the whole thing, 12 3/5 gallons, I just wrote 21 and it's 12. And it's 7 3/4 are mild. 7 3/4 are mild. And then we have extra spicy. How much extra spicy? So this is a subtraction, 12 3/5 minus 7 3/4. And so you can take the whole numbers and subtract. 12 minus 7 is 5. And then we have 3/5 minus 3/4, and we need to get 20ths for our common denominator. And 4 times 3 is 12, and 5 times 3 is 15, and I can't take 15 from 12, but let's do this one. If I have take away from the takeaway, actually, no, let me do it this way. I'm going to do my 4 and give 20 20ths to this one, so we'll have 32 20ths minus 15 20ths, and we'll have 4 and 17. Oops, that's hard to read. 17 20ths gallons are extra spicy. There you go. Okay. 4 and 17 20ths. That's all. And finally, the last one. Jasmine decided to spend 6.5 hours studying over the weekend. She spent 1.5 hours studying on Friday and 2 2/3 hours on Saturday. How much longer does she need to study to reach her goal? Friday, Saturday, Sunday. And we've got the total of 6.5. And Friday is already accounted for, 1 1/4. And Saturday is 2 2/3. So write what you know. Don't know this one. So we need to do this in 2 steps. We need to combine the 1 1/4 plus 2 2/3. And we need a common denominator, but I can do the whole numbers first. So 2 plus 1 is 3. And then I can work on the little fractions next. 3 is my scale factor for the fourth. 4 times 3 is 12, so 3 times 1 is 3. And 4 is my scale factor for this one. 4 times 3 is 12, so 4 times 2 is 8. 8, 9, 10, 11. 3 and 11/12 is how much has been already spent studying hours on Friday and Saturday. But that's not the final answer. I just need to know what is left. So I'm going to take my 6.5, which is the total, and take away the 3 and 11/12. And, you know, some kids will do this in different ways, and that's all right too. A lot of people will end up at the same answer. So, again, so many choices. You can take your 6 and take away the whole 3 and 11/12. So 6 minus 3, well, that's 3, but I still have to take away 11/12. So 2 is left and 1/12. But what about that half? Okay, so you have to put that back, and I can use 12ths. So I'm going to change that to 6/12 because my scale factor would be 6. 2 times 6 is 12. 6 times 1 is 6. And that is what is left, hours left for Sunday. Oh, we are just barely making it. I hope these are helpful. I know there's a lot of information today, but click subscribe if it's helpful. And if it's not, maybe the next one will be more helpful. You guys are the best, and take care. See you.